Scientists around the world conduct research to find answers to their many questions. The fact is, research can never be completed completely perfectly. There is always risk that something along the way will go wrong. There will be pitfalls that we cannot entirely predict. But through experience, researchers have been able to find ways to anticipate these pitfalls and work around them when they do occur. In this video, we're going to be looking at some of those pitfalls, their consequences in research, and case studies to outline what those look like in the real world. Lastly, we'll look at strategies for avoiding and troubleshooting some of those pitfalls, so that you, as an incoming scientist, can be better prepared when you encounter them.
The concept of common pitfalls in experimental research refers to frequent mistakes or oversights that researchers might encounter during the planning, execution, or analysis stage of their studies. These pitfalls can have significant implications for the validity, reliability, and overall success of the research. Thus, identifying these common errors is crucial for several reasons, like ensuring data integrity, upholding scientific rigor, efficient use of resources, enhancing credibility and reputation, contributing to scientific progress, and ethical responsibility. Now we're going to look at the key pitfalls in experimental research. The first one is inadequate planning, which can lead to poor experimental design with consequences like insufficient sample size, lack of control groups, poorly defined variables, and lack of replicability. The second is faulty methodology, which can refer to issues with improper techniques, which leads to things like inappropriate statistical methods, bias in data collection, reliance on outdated methods, and ignoring alternative explanations. The third one is equipment errors, which leads to things like skewed results, variability in data, loss of data integrity, and costly delays and repetitions. The final ones are the different types of bias. Selection bias refers to when the participants are not representative of the larger population. This can skew results and limit generalizability. Confirmation bias refers to the tendency to favor information or results that confirm pre-existing data or hypothesis, which can lead to overlooking contradictory data. And then there's observer bias, which is when researchers' expectations or knowledge about the study influence their observations.
In this section, we're diving deep into the world of research and exploring the often overlooked consequences of pitfalls, from wasted time and resources to potential damage to the scientific reputation. We'll uncover the ripple effects that can occur when researchers encounter unexpected challenges in their studies. Research is a journey full of twists and turns, but what happens when those twists lead to pitfalls? The consequences can be detrimental, impacting not only the researchers themselves, but the entire scientific community. Wasted time and resources are just the tip of the iceberg. Imagine yourself as a researcher, pouring months or even years into a research project, only to discover a fundamental flaw that sends you back to square one. The time and resources invested can be staggering, not to mention the frustration and disappointment for the researchers involved. But it doesn't stop there. Research pitfalls can cast a shadow on a scientist's reputation. Whether it's through publication retractions, skepticism from peers, or public scrutiny, the consequences can be far-reaching. Scientific reputation is hard-earned and easily tarnished. The fallout from encountering pitfalls can lead to a loss of credibility and trust, affecting not only individual researchers, but the broader scientific landscape. Now, let's explore how unresolved issues can propagate incorrect or misleading data. One misstep can lead to a domino effect, influencing subsequent studies, theories, or even policies and decisions. When a study conducted by Daniel Kay and fellow researchers, these psychologists researched the science of error and found that even highly trained researchers, including themselves, often made the same mistake of too much trust in studies with small sample sizes. They published their research findings in a paper called Belief in the Law of Numbers, which served as a catalyst for increased awareness within the scientific community.
Now that we've identified common pitfalls, their consequences, and some relevant case studies, let's discuss some strategies for avoiding these errors and how to troubleshoot them. In terms of strategies, it's important to be proactive in experimental planning. Specifically, it's crucial to define your research objectives with precision and clarity. Take the time to conduct a thorough literature review to understand existing methodologies and potential challenges. This knowledge not only informs your experimental design, but also helps you avoid common pitfalls that others may have encountered. Encouraging the use of checklists and peer reviews in the research process plays a crucial role in preemptively identifying and mitigating potential pitfalls. These proactive measures contribute significantly to the overall quality and reliability of experimental research. Checklists serve as systematic tools to ensure that every critical aspect of an experiment is well considered and addressed during the planning and execution stages. By following a well-structured checklist, researchers can avoid oversights, reduce the likelihood of errors, and adhere to best practices. This not only enhances the robustness of the experimental design, but also streamlines the data collection process. Systematic error analysis is a fundamental approach to identifying and rectifying errors. By thoroughly examining each step of the experimental process, researchers can pinpoint potential sources of systematic errors and implement corrective measures. This method enhances the internal validity of the study, ensuring that the results accurately reflect the manipulated variables. Recalibration of equipment is essential for maintaining the accuracy and precision of measurements. Regular checks and adjustments prevent drifts in instrument performance, reducing the risk of systematic errors over the course of the experiment. This practice contributes to the consistency and reproducibility of results.
We hope this video has taught you why addressing pitfalls in research is so important. We want to remind you that while pitfalls are inevitable, they can be valuable learning opportunities and sometimes lead to results that you never expected. These results can encourage you to come up with new questions that have never been explored before. So as you move through the world of research, we want to encourage you to approach your work and research with diligence, resilience, and a commitment to improving research quality in the academic community.